everyone, this is Teacher Abby, and for today's video, we're going to talk about geometric series. And for this lesson, we need to learn the following objectives. Find the sum of the terms of a finite geometric sequence and find the sum of the terms of infinite geometric sequence. Before we proceed with our discussion, let us read first this problem. Joey saves an amount in his bamboo bank each week. To make it fun, he doubles whatever amount is inside the bank next week. On the first week, he saves 1 peso. On the 10th week, how much will be in the bamboo bank in all? To fully understand the given problem, let us illustrate it. As you can see in this table, on the first row, the number of weeks are written, while on the second row is the amount that Joey will place inside the bamboo bank. As the problem says, each money that will be saved is being doubled up. So if we save 1 peso on the first week, then the amount to be saved on the second week will be 2 pesos, since we need to double up 1 peso from the previous week. Then, from the second week, we have 2 pesos being doubled up, that will be 4, since 2 times 2, that is 4. Then let us do it continuously. 4 times 2, that will be 8 pesos. 8 pesos times 2, that will be 16 pesos. 16 times 2, that is 32 pesos. 32 times 2, that will be 64 pesos. 64 times 2, that will be 128 pesos. And 128 pesos times 2, that will be 256 pesos. And lastly, for the 10th week, we have 256 pesos multiplied by 2, that will be 512 pesos. Now, the question on the problem is, how are we going to find the total amount that Joey saved on the bamboo bank after the 10th week? So, in order for us to know the amount, or the total amount rather, is just we need to add all the amounts that are being putted on the bamboo bank each week. So, we can just add the amount in every week, which is 1 plus 2 plus 4 plus 8 plus 16 plus 32 plus 64 plus 128 plus 256 and plus 512. And if we're going to add that up, that will be a total of 1,023. So, based on that, Joey has a total savings of 1,023 after 10 weeks. And as you can see, in this table, the amount of money can be represented as a geometric sequence, since the rate of money that is being doubled is 2, since it is being doubled up, and the process of getting the total value of the money after 10 weeks is very related to our today's lesson, which is what you call geometric series. In geometric series, we have 2 kinds. The finite geometric series, which involves finite geometric sequence, and the infinite geometric series, which involves infinite geometric sequence. So we're going to talk about the first type, which is the finite geometric series. By definition, a geometric series which is finite is the sum of the terms in a finite geometric sequence. Under the finite geometric series, we have four conditions. And the first one is the most common, wherein we have the formula in which the common ratio should be not equal to 1 or negative 1. If that's the case, we're going to use the formula S sub n is equal to a sub 1 times 1 minus r raised to n all over 1 minus r, wherein a sub 1 will be the first term, n is the number of terms, r is your common ratio, and S sub n is the sum of the geometric sequence. For our example, let us have the problem, find the sum of the first 7 terms of 16, 32, and 64. So the first thing that we need to do is to compute for the common ratio in order for us to know whether the condition that we need is applicable to the formula that is being used. So the common ratio here is the second term divided by the first term, third term by the second term, which is 32 divided by 16, and 64 divided by 32, which is both equal to 2. Therefore, our common ratio is 2, and it is not equal to 1 or negative 1, so we can use the formula a while ago, which is S sub n is equal to a sub 1 times 1 minus r raised to n all over to 1 minus r. And from here, let us find first the given. Our a sub 1 will be equal to 16. Our n is equal to 7 since we're looking for the first 7 terms. And the r will be equal to 2, and we're going to look for the value of the S sub n. So upon substituting the given values, that will be S sub 7 equal to 16 times 1 minus 2 raised to 7 all over to 1 minus 2. In this case, we can simplify here the exponent. So that will be 2 raised to 7 multiplying 2 to itself by 7 times, which is equal to 128. Then we can subtract or perform the operation inside the parentheses. That will be 1 minus 128, which is equal to negative 127. Then 1 minus 2 will be negative 1. So this will be 16 times negative 127 all over negative 1. And from here, we can simplify this problem by simply multiplying 16 by negative 127, which is equal to negative 2032. And dividing negative 2032 by negative 1, so that is both negative, so the answer will be positive. And remember, any number divided by 1 is still the number itself, so that will be a total of positive 2032. So the answer will be 2032 for the first 7 terms of the geometric sequence. For example number 2, find the sum of the first 6 terms of 27, 9, and 3. Again, let us compute first for the common ratio. That will be second term divided by the first term, third term by the second term, which is 9 divided by 27, and 3 divided by 9, which is equal to 1 over 3 or 1/3. Since our ratio is not equal to negative 1 or 1, we can use again the same formula a while ago, which is S sub n is equal to a sub 1 times 1 minus r raised to n all over to 1 minus r. Before we solve, let us find the givens, which is a sub 1, which is equal to 27, n is equal to 6, r is equal to 1/3, and we're going to look for the value of s sub n. Substituting the values from the given, that would be s sub 6 equal to 27 times 1 minus 1 over 3 raised to 6 all over 1 minus 1 over 3. So from there, we're going to simplify first the exponent 1 over 3 raised to 6. That will be equal to 1 over 729. And if we're going to subtract 1 minus 1 over 729 and 1 minus 1 over 3, that would be 728 over 729 all over 2 over 3. From there, we can simplify or cancel out 27 by finding the factors of 729 which matches with 27. So the factors of 729 can be 27 raised to 2 or 27 times 27, which is equal to 729. From there, I can cancel out 27 and this 27, leaving another 27 behind since we have 27 squared. So that will be equal to 728 over 27 divided by 2 over 3, which is also equal to 728 over 27 divided by 2 over 3. So if we're going to get the value of that, that would be equal to 2,184 over 54. And the lowest term for that is 364 over 9. And if we want to solve it for its decimal form, that would be 40.44. So the sum of the first 6 terms of 27, 9, and 3 is either 40.44 or 364 over 9. Since we are done with the discussion of the condition number 1 under the finite geometric series, we're going to have the conditions 2, 3, and 4. Under the condition number 2, this is wherein your ratio is equal to 1. You're going to use the formula S sub n is equal to A sub 1 times n, wherein your A sub 1 will be the first term and n is the number of terms. For condition number 3, your r will be equal to negative 1 and your n is even. So you're going to use the formula S sub n is equal to 0. For the last condition under the finite geometric series, if the value of your r is negative 1 and your n is odd, you're going to use the formula S sub n is equal to A sub 1. And now, let us have more examples. For example number 3, find the sum of the first 25 terms of 11, 11, 11, 11. Again, let us find first the ratio since we want to know the condition. At the same time, for us to know what the formula are we going to use. So, from there, our ratio would be second term divided by the first term, third term by the second term, fourth term by the third term, which is 11 divided by 11, 11 divided by 11, 11 divided by 11, which is equal to 1. Since the ratio is equal to 1, then the formula that we're going to use is S sub n is equal to A sub 1 times n. And we're going to look for S sub 25. And the value for A sub 1 will be equal to 11 and your n will be equal to 25. So that will be 11 times 25, which is equal to 275. So the sum of the first 25 terms of the sequence 11, 11, 11 is equal to 275. For our fourth example, let us find the sum of the first 47 terms of 17, negative 17, 17, and negative 17. So from here, let us find your R, which is the second term divided by the first term, third term by the second term, fourth term by the third term, which is equal to negative 17 divided by 17, 17 divided by negative 17, negative 17 divided by 17, which is all equal to negative 1. Since our ratio is equal to negative 1, and if you're going to notice the value of n, which is 47, which is odd number, then we can use the formula S sub n is equal to a sub 1. And our a sub 1 would be equal to 17. So the final answer for this example would be positive 17. For our last example, under the finite geometric series, let us find the sum of the first 36 terms of negative 14, 14, negative 14, and 14. Again, same process, we're going to find the ratio, which is second term divided by first term, third term by the second term, and fourth term by the third term, which is equal to 14 divided by negative 14, negative 14 divided by 14, 14 divided by negative 14, which is equal again to negative 1. And since our R is negative 1 and our N is 36, which is an even number, then the formula that we are going to use is S sub n is equal to 0. Therefore, our final answer is S sub 36 is equal to 0. Thus, the sum of the first 36 terms of the sequence negative 14, 14, negative 14, 14 is equal to 0. Since we're done with the discussion of the finite geometric series, now we're moving on with the discussion of infinite geometric series. An infinite geometric series is the sum of the terms in an infinite geometric sequence. And the formula that we're going to use is S sub n is equal to a sub 1 all over 1 minus r, wherein your a sub 1 is the first term, your r is your common ratio, and S sub n is the sum of the geometric sequence. Before we have the discussion on the solution of the infinite geometric series, let us find or review first the steps of finding this value. So the first step is determine the value of the common ratio. After finding the common ratio, let us see if it is on these following conditions. Letter A, if your R is greater than 1 or equal to 1, or your R is less than negative 1 or equal to negative 1, then it is impossible to get the sum. Now, if your R is greater than negative 1 and less than 1, then it is possible for us to get the sum. For step number 2, if it is possible to get the sum, then we're going to use the formula. And now, let us have example. For example number 1, find the sum of 8, 24, 72, 216. Again, let us find first the ratio. That would be second term divided by the first term, third term by the second term, fourth term by the third term, which is 24 divided by 8, 72 divided by 24, 216 divided by 72, which is all equal to 3. And since our ratio is greater than 1, then we can say that it is impossible to get the sum of this infinite geometric series. For our example number 2, let us find the sum of 3, 1, 1 over 3. Again, let us find the ratio. That would be second term divided by the first term, third term divided by second term, which is 1 divided by 3, and 1/3 divided by 1, which is all equal to 1 over 3 or 1/3. And since our r is less than 1, we can solve this given sequence. So the formula that we're going to use for infinite geometric series is S sub n is equal to a sub 1 all over 1 minus r. And the given will be a sub 1, which is equal to 3, and the r will be 1 over 3. So we're going to look for the value of S sub n. Substituting the value, that would be S infinity equal to 3 all over to 1 minus 1 over 3. And if we're going to simplify 1 minus 1 over 3, that would be 3 divided by 2 over 3. And every whole number, we all know that 3 is automatically have a denominator which is equal to 3 over 1 divided by 2 over 3. So, solving that one, that would be equal to 9 over 2, or in decimal form, that would be 4.5. So, the value of the infinite geometric series for 3, 1, and 1/3 would be either 9 over 2 or 4.5. Since we are done with the discussion of geometric series, let us have your activity. In your activity, you're going to find the geometric series of number 1, 3, 12, 48. You're going to find 7 terms. Number 2, that would be 2, 6, 18. You're going to look for 6 terms. For number 3, that would be 12, 6, and 3. Number 4, that would be 1, 1 over 5, 1 over 25. And that's all for today. Thank you for watching. If you have questions, you can message me via Facebook Messenger, Abby Mendoza. Goodbye!